here are some sample calculations for a strong base. Just a reminder that the way we do calculations for a strong base is different from the way we do calculations for a weak base. So strong base versus weak base, the calculations are going to be different. Next week in week 6, we'll deal with weak bases. This week in week 5, all we're doing are strong bases. So here are the two formulas we'll be dealing with. pOH and concentration of hydroxide ion. Okay, so pOH is just negative log of the OH minus concentration, and the OH minus concentration is just 10 to the negative pOH. So because this is a strong base, our calculations are a lot simpler than if it were a weak base. If I say to you, all right, you've got a 9.5 times 10 to the negative third molar lithium hydroxide solution, what's its pOH? This is really easy because lithium hydroxide is a strong base, so all I need to do is take the negative log, and there's my final answer. Right? pOH is unitless, just like pH is unitless. Okay, so we can get away with doing this because it is a strong base. If it were a weak base, our calculations would be a little more involved. And now if we want to go the other way, if I give you the pOH and I want to know the concentration of hydroxide ion, the calculations are very similar to a strong acid. If this is the pOH, then the concentration of hydroxide ion is just 10 to the negative pOH. So 10 to the negative 5.44 is 3.6 times 10 to the negative 6 moles per liter. So again, keep in mind, the way we calculate strong acids and strong bases will be different from the way we do weak acids and weak bases. They're much simpler for strong acids because strong acids and strong bases fully dissociate. So just keep that in mind. Next week when we start talking about weak acids and bases, our calculations will be slightly different. But for now, that's all we need to worry about. So, yay!